Okay, so the today's topic is MDF architecture. So we have already seen the overall architecture, how it is this working. But inside the MDF, we have a two files, right? When we create any database, will it create two files? One is MDF file, one is LDF file. MDF file is the master data file, LDF is the log data file. So we have two separate architectures. MDF architecture is separate, LDF architecture is separate. MDF architecture means how the data is organizing inside the MDF file. LDF file means how the data is organizing and working in log data file. NDF also it is following the same MDF architecture only. So first we'll see the MDF architecture. So how the MDF architecture is there? Okay, so the MDF architecture, first I'll explain. This is basically these architectures we can't see 100% practically. We need to assume, we need to analyze, and we need to understand the existing concept, how it is working. We should not come and practically implementing is not possible. We can see some certain levels, but not possible all the things. How the page, how it is page. So this, so we can talk about logically, but physically we can able to see some certain levels. Okay, right. So first, how the data file architecture is there. So the data file MDF file means our whole data is storing into the database. When we talk in general, if we have a database, if you see this database, right? So if you see this database, this is the one database. So if you select any database, for example DB2, inside this database, if you create the table, are you assuming this is directly storing in the form of table in the logically? When we see it, it is showing in a table format. For example, this one. Select star from table name. It is coming data in terms of table format. But actually in disk, how data is storing in terms of pages. Okay, so that is the whole story here. How many pages are there? How it will works? So in SQL Server, the data is storing into the database in terms of pages. We have 9 pages in SQL Server. The pages starts from 0 to 9. Page 0, page 1, page. Okay. Each page having a different name. Okay. The names are like GAM page, SGAM. Okay. Index page, global allocation map. I will show you all the things. And in terms of extents, what is extent? 8 contiguous pages is nothing but extent. Any 8 sequence pages we can call it as a one extent. So in extent again 2 types are there. So we'll see that some more theoretically. I am opening one document. 1 second. Transaction SQL Server architecture. Okay. So these are the simple way we need to understand. See, basically the whole concept of the SQL database, it is not complicated. It is a very simple. When you compare to the your academic subjects like physics, chemistry, so you should not do that much hard work also not required. Okay. So, but there is a planning. So we need to plan, then you will easy to implement. If you don't have the plan, you blindly by hearting and reading the things means it should not be in a correct way. It is very confusion. But here everything you need to make note. So you need to take one book and write down the things, common points, how the structure is there. So I have given the blog, I am sharing some materials. You need to Google it and you can analyze it and you can write down some important points. So like that you can organize. It will be easy to remember for long time. So don't by heart. There is no any theoretical exams. No, nothing is there. Okay. So everything should come into the practical only. 1 second. Why this is not opening? Yeah. Okay. This is one PDF document. So we'll explore some more details in pages and extents. We have total 9 pages. We'll see each and every page how it works. This is the just names we need to remember. We can't see all the pages practically. So how it's working internally, we can able to understand. Okay, right? So you have idea, right? How our operating system is working in terms of binary language. So we need to understand the binary language. We can't see all. If we see also, we can't understand. Like the same way, if you open any page also, you can't understand anything. Okay. Okay. So this is the some more in detail information. I will share this material in the group later. So what is a page? So when you create any database, I told you and I shown you practically two files are created. One is MDF file and one LDF file. But MDF file contains what? MDF file contains, in your assumption, till now, MDF file contains database. Database contains tables. Tables are procedures or views are like that. Okay, that is fine. That is good. But how it is storing internally, that we need to know. So you will get some kind of interview questions from here also. What is a page? What are the different types of pages? How it works? They will ask randomly any page like that. Okay. These are all the very single line of statements. There is no any complicated things. This is the some basic information. What is a page means? Page is a one fundamental unit of storage is called one page. The entire database is storing in MDF file, multiple MDF and LDF files, NDF files. MDF file having so much of space. For example, your MDF file having 1 GB space. If it is a 1 GB space, so many pages are there. But one fundamental unit, we can call it as a one page. That is called the simple definition for the page. What is the page means? A page is a fundamental unit of a storage in the database is called page. Okay. So the disk space is allotted to either MDF or NDF, not LDF. MDF, master data file, or NDF, next data file. If you want to, you can create the multiple NDF files also. Okay, for better performance. These two is divided into a number of pages, 0 to n. Maybe your database having 100 pages or 200 pages or 1000 pages. I will show you where you can able to find out this is it concept. I think you remember when I taken the backup. So after completion of the backup, you will get some output, right? There it is showing 2000 pages processed to 240 pages processed are created. It is showing that type of information. If you want, I'll show once again. So that means in your database having two tables means the two tables is storing in how many pages? There will be one algorithm internally. That is, we need to just know it, not going to in detail how the algorithm is implemented, how it is working. We don't want at all the things. We simply understand it is a storing in terms of pages. What is a page? Page is a fundamental unit of data storage. Next, What is the page size? Page size is 8 KB. Page size is 8 KB. Okay. So 8 KB means in terms of bits, sorry, bytes, 8092 bytes. Simply you can give 8 into 8 KB means 8000. 8000 into, okay, 1 byte equal to 8 bits, right? So you can simply divide into 10024, you will get some value. That is this value. 8 kilobytes means 8192 bytes. Again, you want to in terms of bits means 8192 into 10024, you will get in terms of bits, but we don't want that all in detail. Just simple. A page is 8 okay, 8 bytes. 8 KB is the page size. Let's come to the next point. What are the different types of pages? So we have total 9 pages are there. So we need to understand the simple names. The first page is called data page. Second page index page. Third one text or image page. GAM page. SGAM. GAM for global allocation map. SGAM for shared global allocation map. PFS means page free space. IAM means index allocation map. BCM means bulk changed map. And last one DCM is differential changed map. Okay, I think you got some idea, right? If you store a data in the table, if you create a one table, you are storing one image, one video, one audio, one text message. These type of informations you may store into the database, right? So if in that case, how the data is organizing, all are not blindly going and storing in a one page. No, there will be a bifurcation here. If it is a normal data, go and store in this page. If it is a image in this data, you go and store in this third page. Okay. If you have any indexes, go and store in the index page. If you have any bulk operations, go and store in the bulk change map. Like that, there will be different categories of pages based on your data. The data will be stored automatically into the corresponding page. This all will be done internally by SQL Server operating system. We are not doing anything. Okay, just we are need to learn how it's working. Okay, data page means how, what type of data is storing. It will store all types. It will store all data. Okay, it will store all rows of data except text, n text, image, n varchar, max. These are all the data types in SQL. So it is not storing text information, large volume of paragraphs. It is not storing into data page. When you store any photos, it is not storing into data page. If you are storing any n varchar, max, all these things, that won't store. So like that, there will be exclude operations. What you need to tell the answer, database stores only normal data, yeah, not storing any images or binary data. Like that, index page means information about only indexes. I will show you. Okay, every table we can able to create some indexes for better performance. Index means it is order. When you open your textbook, if you purchase any textbook, the first page is called the index page. What it contains? It is the number sequence order. Where is the first unit? Which page? Second unit? Which page? So and so topic? Which page? Like that, we can easily to go to that page, right? The same way, if you create an index for the table, okay, I want fifth record. So if it is automatically going to fifth record very fastly. Like that, the index page is working. Next, images. If you want to store large volume of images or videos kind of things, it is storing into the image format. Text means large volume of data. Like that. So each category is the simple definition. GAM means information about whether the extent is allocated or not. First of all, what is extent? I already told you. 8 consecutive pages is nothing but extent. If your data is more than 8 pages, then it is automatically converted into extents, right? That extent is there. How many extents? Everything is storing into the GAM page. Okay, next one, it tracks mixed extents. SCAM means I already discussed two types of extents are there. Okay, uniform extents and mixed extents. Uniform extents means stores only one type of object. That means either table or either procedure or either view, only one table it can store. If it is a mixed extent means if you have 8 pages, one page may store table, one page may store view. Someone is unmuted, please mute. Okay, like that. Mixed extents means it should not waste any pages. It is effectively utilizing. Uniform extent means if you are storing table, only tables are storing. Maybe your table can store in 3 pages, remaining all 5 pages are waste. That will be a different between the uniform and mixed. Like that. Next to PFS, information about the allocation of the free space is available. How much free space is available for that page? That is handled by the PFS. IAM page, information about the extent used by the index for allocation. Index, how much space is there? Next BCM, bulk operations if you perform, that what changes you have done, that everything is stored in the BCM. DCM means okay, the information about when your last backup taken, all kind of information is storing into the DCM page. So like that, every page having some specific meaning, it will store on separate way. So if you show some more additional details like this, the every database is storing in terms of 0 to 9 pages total. So what we discussed till now, is the 8 pages. There will be a one more page is called, okay, boot page. Boot page means just like a boot loader program, how it is working in Windows, same way, how the database is loading, that everything is done by the boot page. And first one is the header page. So the remaining all 7 which we discussed just now, that everything is the total 9 pages. So we'll see how it is internally there. It is the structure. Okay, this is the complete, it is the one page. Header information, data 1, data 2, all records are storing. If you have any free space, it is empty. Like that, data is storing. Some more additional information. So just please go through it. I'll come to the next one. Extent. What is an extent? Extent is nothing but 8 physical contiguous pages. Contiguous means it is a sequence. Continuous 8 pages is called one extent. You should not go and tell first 2 pages. Again, after some gap, again take 2 pages. You should not call that is not extent. Okay. 8 contiguous pages is called one extent. 8 means each one is 8 KB. 8 pages means 8 into 8, 64 KB. One extent size is 64 KB. This is the fixed. Okay, Microsoft is defined. Let's come to the types. Two types of extents, right? I told in the earlier, uniform extents and mixed extents. It is very, very simple. The name itself is telling if it is uniform extent, it can store only one object for the entire extent. For example, if you have one table, the entire uniform extent is storing your one table only. Okay, how much space is there, that will be stored, remaining is waste. The mixed extent means if you have one table, one procedure, one view, like that different objects are there. Okay, so for example, in the mixed extent, maybe your 2 pages stores the first object table, and the remaining don't waste. It will reuse for the next objects like stored procedures. It can store views it can store, because it is a mixed. All things are available in the one extent. But when coming to the uniform extent, even though if procedure view and table is there, but it will store each and every object in a separate uniform extent. One extent for table, one extent for view, one extent for procedure. If you do going in that way, so much of internal space is waste. When you go to the mixed extents, it will be reuse the space effectively. It can store in one extent all objects. That is the one advantage and disadvantage. So basically, when you create any new table, for example, fresh table, which one is going to be allocated first? The SQL Server architecture. If any new table or index in generally allocated to mixed only. So don't go to the uniform. It is by default, it is the mixed extents. That will be the best because it is not wasting more. So some more definitions, okay, some more informations. When a table or index goes to complete the eight pages, it will automatically switches to the next uniform extent. So how it is working? First starts with any table or anything you created. First starts with mixed extent will created. If mixed extent 8 pages are completely filled, then it will create the uniform extent. So subsequent like that. Okay. So if you go and see some more pictorial way, this is the first one is the mixed extent, second one is the uniform extents. If you see the color representation, okay, in this mixed extents having table is there and index is there, index 2 is there, tables, indexes mixing, it will store it. Index is also an object. But when coming to the uniform extents, all are tables only. Table 1, table 1, table 1. And that means it should not allow other table, even though free space is there. If any table to come, again it will create one more extent. So that is the drawback. So this is about the whole pages and extends MDF architecture. So this is the whole agenda here. Okay, even though if we create the file groups also, file groups, see how the data is storing, right? First is the database. Inside the database having your MDF, LDF files. MDF, LDF files contains your pages. Pages contains actual data. But before going to the pages, the data is partitioning. First, database contains MDF, LDF. MDF again divided into number of file groups. Each file group may having, okay, MDF, LDF files. Each LDF, MDF file having pages or extents, like that it is storing. It is the hierarchy. Okay. See, for example, if just I am taking one backup, you can't see the pages practically. Okay, just how it can work, you can able to see. For example, now I am taking one backup, right? There will be some couple of commands. If you want, you can see in the query way. See, okay, now I am starting one backup. See, when you take your backup, which page is working? Differential code map, DCM page. Just for interview purpose, interview questions purpose only we need to know. Otherwise, not much focus is required. Okay. So I'm taking one simple database backup. I will show you where the pages is coming. Okay. Take what is the DB name? DB3 underscore backup dot BAK. Okay. Now I'm clicking OK. If you see the, sorry, if you take this, you can't able to see. 1 second. I will execute from the command itself. See, I will show you one more thing. If you want to, if you don't know the command, for example, but you want to get the command script, so you can generate the script also. I will show you. Okay. So just click it. Script will be generated. So here the top there will be an option called script. When you click it, whatever the options you selected, it will come automatically. See, if you don't know the backup syntax, for example, basically everyone should have the idea on the backup command. If you don't know also, you can generate the script from the GUI itself. Just there is a top script button. Once you select all the options, if you not select, it don't come. All are coming empty. If you need to select the backup path and everything, don't click OK. At the final, you can click the script button. You will get the command. So this is the backup database name to disk equal to our normal path name. We are specifying till now only, but some other parameters is also coming. This is the good way of making no format, no init. Okay. So what type of backup you are taking, that some additional information is coming. So when you make it stats equal to 10 means for every 10%, 10% your status is showing 10% completed, 20% completed, 30% completed, like that. That would be the easy to. So when I click this, the backup will be taking. Okay, see, if you see this one, how it is showing some kind of information, right? 10, 20, 30, 40, 50. Okay, so what it is showing here is after 90, processed 344 pages. That means how the data is storing inside the MDF, you got to know, right? 344 pages for database DB3, file DB1. Okay, so that means in this MDF file, 344 pages are there internally. Okay, next 2 pages for LDF file. If you see this one, db1 underscore LDF, this is the file 2, this is the file 1. For log file, there is very less number of pages, only 2 pages are there. The data having actual data, so we have more pages. So total 344 plus 2 total. In the last command, backup successfully processed 344 pages in 0.659 seconds. Okay. So that is the total way how we are taking the finding the pages. If you mention here, if you mention one, it will show every 1% like that. See how it is showing 1% process, 2% process, like that. it will show. That is up to our choice. Okay. So this is the way we can show how the pages are processed internally. Okay. If you go and see the down, so here also it will show total 344 pages for an MDF file, 2 pages for LDF, total 346. This will be the depends on the size of the data. The pages may be varied. Sometimes it may come thousands, lakhs of files also, pages also. Okay. So that's all for the today's agenda. So any doubts, please reach out to. So then we'll explain the log architecture tomorrow. So then you will get to know how it is there in the mostly. Then we'll go to the next level of things. Okay. So these are all things we have done. Security principles and permissions that you need to make it more clarity. Backups and recoveries is also done. Restorations is also done. Okay. So then we'll move on to the next some kind of scenarios. Okay. Then we'll see the automation, how it works. Okay, agent jobs. That's all for today. Stopping recording.